between the independent variables and dependent variables. So basically what it calculates is how independent variables or how much the independent variables are influencing the dependent variable, because there can be more than one independent variables and there can never be a exact result for it. So we usually calculate it approximately, or we usually approximate it. Now how can you actually go or study it is, let's suppose that you own a business, and as you own a business, there in every month the sales comes down, the sales comes up. There are a lot more sales than the last month. For instance, there was just a pandemic that actually influenced a lot of business and something like that. Now the rainy weather is over here, and that also impacts a lot on the businesses. So like there are a lot of different factors. There is a factor of season, there is a factor of the weather, there is a factor if there was a pandemic or not, or there can be a lot more factors, the work environment, the colleagues, the boss, and the workload, all of this. So all of those independent variables actually are correlated to the dependent variable, that is the sales. So how the weather is the independent variable, and that is affecting the dependent variable, that is sales, because if the weather is not good, there will not be any good sales, but if the weather is good, there will be good sales. If there is the season of that material, of the demand is a lot greater than the other seasons. Similarly, if the work environment is good, the employees are happy. If their pay is good, they work more efficiently and then more whole. Graph in front of you, you will see a lot of blue dots. These blue dots that you are seeing is let's suppose it is your 1 month's data, and it is relating to how much it rained that month and how much sales you made that same month. इस महीने में कितनी बारिश हुई है और उससे आपकी सेल्स पे कितना असर पड़ा है. Imagine drawing a line in between the middle of the points, connecting the certain points, which helps you create a straight line, and that red line is known as regression. Draw the line, and we can use a lot of softwares. We can use SSPS, if you know about that. That is very helpful in creating the regression lines. Okay, and it shows the line that best fits the data. Let me give you an example of myself. So let's suppose if I travel more, I eat more, and I gain some weight while traveling. So I cannot say that traveling gives me more weight, or if I travel or if I am on the road, I gain weight. That's not the cause and effect relationship. Regression analysis is not a cause and effect relationship. We have to look into the factors that what specifically is affecting and causing the weight gain. So what actually is causing the weight gain is, if I'm on the road, if I'm traveling, I might eat more. And why do I eat more? Maybe because I'm nervous and because I have nothing else to do and I'm kind of bored, and these are the factors that are causing me to eat more, and that is the factor that is causing me to gain some weight. So that is the regression analysis. So we are going to go to probability theory as well. So probability theory is a branch of mathematics, and it gives you a number. It gives you the number of probabilities of and tells you that what are the chances of an event or something happening. So if you toss a coin, most easiest example, there are half the chances of coming of heads as there are half the chances of coming of tails. But that does not define you that what your outcome will be. You can never know what your outcome will be unless the outcome comes out. Since if I'm tossing a coin, there can only be two outcomes. Either it can be tails or it can be heads. Or if I'm rolling a dice, and for that there can be 36 outcomes. It can be one. So the next one is multinomial probability. Now what is multinomial probability? So let's suppose if you have red balls and black balls. Supposing black balls are denoted by B and red balls are denoted by R, and you can take I red balls. Let's suppose the number of balls that you're taking at once is I. You're rotating it, and you can take I red balls n times. You can just take them n times. I don't know what n is. Let's just assume that. So since you are drawing each of the ball, each drawn will be denoted by R plus B. And it can be n times, it can be a lot of multiple times, so it will be R into B, R plus B whole power n, because we are taking it out n times. And that is the possible outcomes of this experiment. Last but not least, I just want to talk about sampling, what it is and how is it done. So if I have a population, that is a statistical population that I am applying my statistics on, and I want to analyze the characteristics or attitude of the whole population, I'll be taking a sample from the whole. And usually I do that by maybe surveying, or maybe interviewing some of the people, or maybe passing a questionnaire. That is the most easiest way to analyze your sample space. Sample space is usually taken out of the whole statistical population. So basically, according to methodology, we use a sample space from a larger population depending on the type of analysis that we are going to perform. So if we are performing a different kind of analysis, we use that kind of sample space out of the population. So that was all about sampling, and I hope you guys understood what I was talking about. And if I was being a bit too, I don't know, hard to understand, then just let me know in the comments down below. And if you have any questions, just write it down below, and I'll try my best to answer those questions as well. And I hope you guys enjoyed the video, and even if not enjoyed, I hope you understood the video, because that's more important. And just comment down below and let me know whatever you think of it. See you guys.